symmetric key cryptography that we are going to see later on, which is also known as secret key cryptography, the sender needs to share the key with the receiver in a secure way. Okay, the same key the sender and receivers will be using. So there comes the problem of sharing the key. How securely the sender is going to share the key with the receiver. So again, that can be achieved using the cryptography. Okay, so all these things we are going to see. So encryption is the process of converting data written in plain text into ciphertext. Plain text is something which is readable and understood, and ciphertext is something which is coded and appears meaningless. Decryption is the process of converting ciphertext back to plain text. Key. The encryption process requires cryptographic key that tells the algorithm how to transfer the plain text into ciphertext. And key is also used to convert ciphertext back to plain text. So see, so encryption and decryption, the data which is encrypted can be decrypted back using the key. So this is yes, Mihir, quite possible. Okay, you can try it in your own account only. You can try it, but let me tell you, nowadays Google has become very smart, Gmail, okay? So that email which you are going to send will not directly go into the inbox of the sender. Maybe first time it will go, okay? I'm pretty sure first time it is going to go into the inbox of the sender, but otherwise it will go in the spam then, okay? So Google has used some filters over there, and that's why it is secure nowadays. But if you take Yahoo or something, okay, you know, it is definitely possible that the email will directly go into the inbox of the receiver. Yes, it is possible if you are tracing the mail. Later on, I will talk about how to trace the email. It is possible to trace the sender. Perfectly possible. Okay. So encryption and decryption. Plain text. Plain text using the key. Okay, so it is known as encryption, can be encrypted and it is converted into ciphertext, and ciphertext can be decrypted and again converted back to the plain text. So in this case, the same key is used. Okay, same key is used for encryption as well as decryption. So this is known as symmetric key cryptography. So encryption can be used to encrypt your entire hard disk. Today I will show you how to encrypt your entire hard disk. A specific drive or some partition of a hard disk. Maybe I will use this second option because first will take a lot of time. Okay, so I will show you the second option, how to encrypt your specific drive or partition. Some specific folders is also that we can see today. Specific folders or files on the hard disk, and external removable storage devices like USB pen drive. Or so see, everything can be achieved using encryption. And this is how we are going to secure your data. We are going to protect your data. Limitations of encryption. Encryption does have some limitations. And what is that? It is not going to protect you against malwares and against the rootkits. Okay. So don't be under the impression that if you have encrypted the folder, then it cannot be, means virus cannot enter into that folder or file. It is not like that. Okay. So it is not the substitute for your antivirus definitely. But yes, it is going to protect your data from, I will say, going into the hands of unauthorized person. What are the benefits of hard drive encryption? Today we are going to talk about this hard drive. Okay. So there are, and if I ask you this question openly, then definitely you are going to give me lots of answer. So there are lots of benefits definitely. So yes, it protects from data disclosure stored on your hard disk in case your device is stolen or lost, especially the laptops. Okay, so laptops are the devices which can be stolen, right? As compared to the desktop computer, it is very easy that you may lose your lose your laptop. And what if that laptop is holding some confidential data? Okay, so that is always good idea that you should encrypt your hard disk. Now see, there is one attack, tailgating attack, that we have seen our yesterday's session, right? Tailgating. You remember tailgating? Your just entering into some premises, right? This is a door. You are swapping your card. You are swapping your card, and somebody is requesting you to let him go inside because he or she has forgotten his badge today. Okay, or maybe forgotten his card today. So personally, you don't recognize or know that person. Okay, but because just merely looking at that person, or maybe that girl, or maybe that lady, you are just allowing her to come inside. This happened in one of the IT company, okay, in Pune. And you know what happened that day? That lady entered that premises, and that day 3 laptops got stolen from that office. 3 laptops. So it is not the matter of money now, you know, because just 80,000 or 1 lakh is not a big deal for any particular company maybe. But what is important, the intellectual data that hard disk was holding. So there comes the problem. So see, here we can see the tailgating was the attack. Tailgating was the attack, or piggybacking, which we have seen yesterday. So that is the form of the social engineering attack, right? So using that, somebody has entered the premises and stolen the laptop, and laptop was holding the confidential data. So if that laptop was encrypted, maybe then that organization would have saved lots of its data. So yes, protects the data from disclosure in case your device got stolen. And something maybe you must have experienced this. I had experienced this. Okay. So one day my laptop failed to start. Okay, it was not at all getting started, and I have to take it to the service center. I have to take it to the service center. And you know, that laptop usually, my second laptop usually is having lots of important data it is having. And then I was little bit worried when the person asked me to share the password of my laptop. Okay. So see, this may happen. This may happen. So protects your data on hard disk from disclosure if your device is sent for repair. Now, if your computer is having a hard disk, C drive, we usually having the operating system file, right? We don't keep any confidential data over here. So what should have done? So I usually create a separate drive, and it is having all the data, and then you encrypt this drive. Don't encrypt your C drive. See, now in this case, what will happen? Even it happened that you are going to send your laptop for repair, right? So your D drive is encrypted. So that person will just need access to the C drive only, right? So he will definitely not need any access to the D drive. At the most, what will happen? He will need to format the entire disk. Okay, so that we have already seen. You must have a good backup. You must have a good backup of your data. So you should always have a good backup, and your drive is encrypted. So when, even if you have sent this laptop for repair, nobody will be able to access your data if it is confidential. So these are the, I have written it myself. Okay, so I have just seen what difficulties I have faced. Okay, and what are the advantages of having this encryption. Fine. So what are the types of encryption? Asymmetric as well as symmetric. In asymmetric encryption, asymmetric, okay, asymmetric, not symmetric. It is also known as public key cryptography. Asymmetric encryption encrypts and decrypts the data using two separate yet mathematically connected cryptographic keys. Now, folks, try to remember your public key and private key in AWS. When we create our EC2 instance, right? When we launch our EC2 instance, you have to create a key pair. And that key pair is actually combination of private key and public key. The private key gets downloaded on your laptop, right? And the public key resides in the EC2 instance. So when you are trying to establish the SSH connection with that EC2 instance, you have to provide the appropriate private key which matches with this public key. So see, although these are separate, they are mathematically connected. So what actually happens in this public and private key, you know? See. So in this public key cryptography, we are having two keys, public key as well as private key. Now, let us say this is Alice, who is the sender of the data, and this is Bob, who will be received the data. So these two people wants to communicate with each other, but securely. So Alice will have her public key and private key. Similarly, Bob will also have his public key as well as private key. So this is a key pair. This is key pair of Bob and this is key pair of Alice. Now, public key are something which you can share with each other. Okay, so they are not something which are very confidential or something. Just to give you the example, okay, just the analogy, not exactly, okay. So just think of your email ID. So unless and until you share your email ID with somebody, okay, so nobody will be able to send you the mail, right? You can't say that I will not share my email ID with anybody. Okay, so then it will be useless, right? So email ID is something we usually share. Okay, so but what about your inbox password or your Gmail's password? Do you share with anybody? Definitely not. Okay, so I will say you are the only person in the world probably that who is knowing your email's password, right? So you can compare this email ID with the public key and the inbox password with the private key. This is just the comparison, okay? This is not the exact one, but yes, you can compare it. So public, now Alice and Bob wants to communicate with each other and that too securely. So what they will do, they will share each other's public key. So Alice has shared her public key with Bob and Bob has shared his public key with Alice. So both of them know each other's public key and now their private keys are confidential. Now Alice is the only person in the world that she knows her private key and similarly Bob is the only person in the world who is having access to this private key, his private key. Okay. Now, one more thing, this public key and private key will work. So whatever has been encrypted using Alice's public key, okay. Now data can be encrypted using this key also and this key also. Remember, so you can encrypt the data using public key as well as private key. But what is the thing? If it is encrypted with Alice's public key, then it will only be decrypted using Alice's private key. And vice versa is also true. If the data is encrypted using Alice's private key, then it will only get decrypted using Alice's public key. Got it? So similarly, if the data is encrypted using Bob's public key, it will be decrypted using his private key. And if it is encrypted using his private key, it will just decrypted using his public key. So these two keys are connected to each other and you can use any key to encrypt and the reverse key has to be used to decrypt the data in that case. Okay. Now see, now we will elaborate the scenario. Now Alice wants to send one confidential data. Okay. So she has created one file. Okay. She has created one file and she wants to send this as an email attachment to Bob. She knows Bob's mail ID. So it is Bob at the rate, let us say gmail.com. She wants to send this file to Bob, but she wants to make sure that only Bob should be able to read this file. Nobody else should have access to this file. She wants to achieve confidentiality. Okay. So what she will do now? So now Alice knows three keys. Okay. What are the three keys Alice is aware of? Alice knows her public key, her private key, and she also knows Bob's public key. Okay. Alice also knows Bob's public key. Similarly, Bob is having access to three keys. His public key, his private key, and Alice's public key. Okay. So again, Bob is knowing three keys and Alice is knowing three keys. Now, what Alice will do to achieve the confidentiality? She will encrypt this file. Okay. So in short, we'll just, this is the file. Okay. Now she wants to share this file with Bob. So what she will do? She will encrypt that file. In short, she is just putting it in the envelope. Okay. Now she is going to seal this envelope. Now she is going to lock this envelope. Okay. And which key she is going to use to lock this file so that only Bob should be able to read it? Anybody?
Private key, Alice.
Whose private key?
Bob.
But Alice doesn't know Bob's private key. Bob is the only person in the world who knows his private key.
Then she uses public key of Bob.
Yes, she uses public key of Bob. See, now what she has done? She has locked this envelope. Okay, so she has encrypted this. Now, as we have seen, if something is locked using Bob's public key, then it will only get open using Bob's private key, right? So once this envelope is locked, who will be able to open this envelope? Only Bob, because Bob is the only person in the world who is knowing the private key, right? So now nobody other than Bob will be able to read that file. So this is what the confidentiality is, right? Nobody else other than Bob will be having access to this file because it is encrypted using Bob's public key. Now, once Alice has encrypted that file using Bob's public key, now see, even she will not be able to open this file because now it is locked. She is not having this key. Only this key is able to open that file, right? So this is what the confidentiality is. Let us go one step ahead now. So Alice has created this file and she has put it in the envelope using Bob's public key. Okay, so this we have seen. So it means that this envelope can be opened using only Bob's private key. So in short, only Bob will be having access to this data. Now the mail was sent by Alice at the rate gmail.com. Okay, and the receiver is Bob at the rate maybe gmail.com. Okay, now once Bob receives this mail, okay, once Bob receives this mail, Bob wants to make sure that this attachment has been sent or this mail has been sent by Alice only. Nobody else has sent this email. Just like the website I have shown you, the fake email sender, right? So that EMKEIZ, so that is the website. EMKEI.cz is the website which is used to send the fake email. So anybody can send this mail, right? So but now Bob wants to check or wants to make sure that Alice has sent this file, okay? Or even Alice wants to tell Bob that she is the person who has sent this email, right? Now what Alice will do? Alice will put it in one more envelope now. And she will seal this envelope again. Now see, this is the second envelope. But this time, Alice will use her private key. Okay. So see, first envelope, she has locked using Bob's public key. This was Bob's public key. But the second time when she has put it in the envelope, she has used her own private key. Now see, now this envelope will reach to Bob. Now Bob wants to read this file. So first he needs to open the outer envelope, right folks? He needs to open this outer envelope. So which key Bob will use to open the outer envelope? Anybody?
Alice private key.
No.
But ma'am, it is Alice private key at the end.
It is locked with Alice's private key. So what I told you, if
Alice
it
public
is
key.
encrypted with Alice's private key, then it will get open with Alice's public key, right? If something has been locked with Alice's public key, then it will get open with private key. This is what the encryption is. Now, if the outer envelope is locked with Alice's private key, then it will get open with Alice's public key. You got it now?
Yes, ma'am.
Yes. Now see, now Bob wants to open the outer envelope. Then he will use Alice's public key, right? So using Alice's public key, this envelope will get open. But now what it proves? What it proves? Now, if that envelope got open using Alice's public key, it means that it must have been locked using Alice's private key, right? because it was open using Alice public key, it must have been locked using Alice private key. And who is the person in the entire world who is holding that private key? It is Alice only. Nobody else than Alice is having that private key. So it means that this mail is sent by Alice only. Nobody else than Alice has sent this mail. Why? Because it was locked with Alice private key. And Alice private key belongs to Alice only. Now see, it is not going to have that security as well. Let me just tell you. So Alice, because we have just seen this envelope can be opened using Alice public key. And Alice public key is really public. Not only Bob, other people also know what her public key is. So that is perfectly fine. So anybody can open that envelope using Alice public key, but they will not have data to the inner envelope basically, right? So what actually it means if you are able to open the outside envelope, it means that the mail has been sent by Alice only. So Alice is the sender of this mail. So that is what we can achieve the non-repudiation here, that Alice is the only person who has sent this mail. Okay, so fine. So Bob was successful in finding out that Alice is the only person who has sent this mail. And now he wants to read this file. And for that, because it is been locked using Bob's public key, okay, so Bob will use his private key to open this file. And Bob is the only person who is having the private key. And once Bob opens, so only Bob will be able to open this file and read this. Any question regarding this, folks? Are you finding it difficult or is it clear?
Ma'am, clear.
So now, when you lock something using your private key, okay? So when you encrypt something using private key, it is known as digital signature, okay? Encrypting something using your private key is known as digital signature. So what exactly digital signature in the real world will look like? Let me tell you. Now let us say Alice has created this file, okay, and she is supposed to send it to Bob using encryption. Okay, so we know that she will encrypt it using Bob's public key, right? She will encrypt it using Bob's public key and then she will send to Bob. So Bob will use his private key to open this file. Bob will use private key to open this file and then Bob will have access to the file. Yes, Lucky. It is also possible. Using blockchain, you can also achieve these things. Okay. So now let me talk about digital signature. Now what Alice will do, see. Now Alice will create the file. Okay. So I actually show you how it will look. Okay. So what she will do, she will create some file. For example, this is the file. Okay. This is the very confidential data Alice has created. Now what she will do, she will create hash of that file. Okay, so for that we already know, I have already shown you this tool. Okay, so this is, let us say, online hash calculator. Okay, so let me just go there. Definitely you should not use such online tools. Okay, so if it is really my confidential file, then why I am going to use this website, right? So definitely you should not. This is just the demonstration. So I will go to my okay. So this is the file, okay, and calculate hash file. And let us say I'm interested in using this algorithm, SHA 256. So what will happen, you know? Okay. So what Alice has done? Alice has created this file. Okay, Alice has created this file. So for the time being, assume that this file is my file 1. This is the file which Alice has created and it is her confidential data. Then what she has done, she has computed the hash value of that file. And this is the hash value. Okay, this is the hash value. And now what she will do, she will encrypt this hash value using her private key. So see folks, this is what happens. So she has created a file. First of all, she will calculate the hash value of this. As I told you, it is a string, right? It is a string of numbers and letters. So for example, 1, 2, 3, 4, 5, 6, 7 something is the hash value of this file. Now she will encrypt this one using her private key. Using her private key. See, so she has calculated the hash value and she has encrypted it into using her private key. Fine. So this is one process. This is one process. And secondly, she will encrypt this original file using Bob's public key. Okay, so she just know Bob's public key. She will definitely not know Bob's private key. But if something is encrypted with Bob's public key, it will get open only with Bob's private key. She knows it, right? So she want the same thing. She want only Bob to open this file. So what she has done now, she has encrypted the original file using Bob's public key. Okay, but before doing that, before going for that encryption, she has calculated the hash value of that file and she has encrypted that hash value using her private key. Now see, she will send both these things to Bob now. She will send both these things to Bob. Now what Bob wants to make sure now, so see, now integrity is also coming in picture. Not only integrity, confidentiality as well as authentication. So we are achieving all these three things in this example. Now see what happens. So first of all, only Bob will be able to open this file, right? So Bob will use his public key and Bob will use his private key because it was been locked using Bob's public key, right? So Bob will use his private key to open this file. Perfect. Okay. So fine. And now what Bob will do? Bob will use the same hash algorithm to compute the hash value. And he will compute the hash value. Okay. He will compute the hash value. So for example, hash value of Bob is 1, 2, 3, 4, 5, 6. And now what he will do? He will again open this attachment. Now it was locked with Alice private key. So he will use Alice public key to open this. So once he open this file, he will get the hash value. And now he will compare the value which he has computed and which Alice has sent. If these two values are matching, that it means that the file is intact. Okay, nobody has made any changes in this file. So it is the integrated one. Okay, so not only that, because this hash value was encrypted with Alice's private key, and that is the reason Bob was able to open it with her public key, right? So because Bob was able to open this file using Alice's public key, it means that it was locked using Alice's private key. And Alice's private key just belongs to Alice only. So it proves that this hash value has been encrypted or has been sent by Alice only. So now we can call this actually as a digital signature. Okay. So encrypting the hash value of some document, encrypting the hash value of some document using your own private key is known as digital signature. Is it clear, everybody, now? Is it clear what exactly the digital signature is? So now the sender is proving that he is the person who has sent this file using the digital signature. Okay. So any question you can ask me. Now let us go for this. Okay. Cryptography is the discipline that embodies the principles and techniques for providing data security, including confidentiality as well as integrity. Encryption is the process of using a code called cipher to turn readable data into unreadable data for another party. The cipher contains both algorithm to encrypt as well as to decrypt the data. A key is a series of numbers and letters that the algorithm uses to encrypt and decrypt the data, and only the owners of the key can encrypt and decrypt the data. So now see this was the original text, AWS rocks. Okay, it was encrypted, and let us read this one. Okay, people have been using codes throughout history to keep information from others. Spies, governments, and others have used codes and other methods to ensure that only certain people can read messages. Cryptography is the discipline that embodies the principles and techniques for providing data security, including confidentiality as well as integrity. It is a collection of practices that take advantage of modern computing technique. It provides a level of confidentiality and integrity of the information to secure and maintain access to sensitive information. Cryptography is not encryption. Encryption is piece of it. So see, cryptography is the art and science, I will say, of securing the data. But encryption is actually the process. Okay, how are you securing it? So encryption is the part of cryptography. Cryptography in itself is a vast term. Encryption is one of the feature of this cryptography. Encryption is key to ensuring data confidentiality. Imagine that you want to carry a document in a simple USB pen drive, right? Note that this method is not the safest way to share the document, although. Okay, fine. So you have put some important document in your USB pen drive. If you lose the key and did not encode the document, your data is at risk of being stolen, read, and used. If you encrypted the document with key, your document is secure. Only those users who have the key to decrypt the document can read it. I have personally experienced this one. I don't know whether I've shared this with you. One day it happened with me. I have to take the print of my passport. Okay. And my printer was not out of that ink. Okay. So I have to take it to the shop where they are giving me the printout, right? So what I did, I have copied my passport in the digital copy of my passport in the USB hard disk. I went to that shop. I have taken the printout. Okay. And I left my pen drive there. I think pen drive is the device which is meant for losing. Okay. Everybody must have lost their pen drive sometime, right? Somewhere, sometime, everybody must have lost the pen drive. Now, it was not the matter of that drive I was having. Okay. It was just a cost of maybe 300 or 500 rupees of something. Okay. But it was the document that USB pen drive was holding. But the shopkeeper whom I usually visit, I trust that person. Okay. I'm knowing him since years. So it was not a big problem for me. Okay. So he called me. He told me that I left my pen drive there, and then I went again and I have collected it. Okay. So now just try to understand, what if it is not the shop and I left it on the road or something. Okay. So it would have been a great problem for me. So that is the reason you should always, if you are carrying some confidential data into that USB hard disk, you should always think of encrypting that pen drive. Okay. You should always encrypt that pen drive. So I will show you how to encrypt that pen drive as well. Okay. So now if the pen drive is encrypted, it will first give you one password. Okay. And only the person who is knowing the password will be able to open it. Okay. So I definitely, if it is my pen drive and I have encrypted it, I am the only person who knows that password. Now, even if I lost that pen drive somewhere, okay, at the most, what the person who is going to get my pen drive will do, he can format it. Definitely, he can format it and he can use it. That is not a problem. Okay. But he will not have access to the data which that pen drive is actually having. And this is what I mean by confidentiality. You can achieve the confidentiality not only of your USB hard disk, USB pen drive, it could be your entire hard disk, your entire or maybe any particular drive of your laptop or something. I personally experienced this, and that's I wanted to share with you. Okay, fine. So what data must be encrypted to stay secure? So I will say your personal identifiable information. All your PII should be encrypted. Practical uses of cryptography: encrypting a file system, drive encryption, computer to computer instant messaging and secure email, secure socket layer SSL and Kerberos. Okay, so these are used for encryption in transit, these two methods. Okay, encryption in transit. But even cryptography or encryption can be used to protect the data which is at rest. So to protect your data which is at rest and to protect your data which is in transit. So you know now, when you use HTTPS, what exactly that HTTPS means? What exactly that HTTPS means? Actually, HTTP is the protocol we use, right? To transfer, or it is the protocol from the web browser of one computer to the web server, right? So the data from web browser to web server, it's getting transferred using this HTTP protocol. But now this HTTP is not secure. It is the plain text protocol. So whatever the data is flowing between these two computers will be in plain text now. Okay. And that's why nowadays no website, I will say, will use this HTTP. So they are using something which is HTTPS. Now this HTTPS, this S in HTTP, it stands for secure. But what I mean by that secure, it stands for SSL TLS. Okay. It stands for SSL TLS. So this is the encryption which we use when connecting to the servers on the internet. It stands for secure socket layer, transport layer security. Secure socket layer / transport layer security. In fact, we are not using this SSL as well. We are just using this TLS nowadays. Okay. But now it has become a, I will say, practice to use this together. Okay. So that's why we call it as a SSL TLS encryption. So how this encryption work, that also we are going to see later on. Okay. But this is what this SSL is. Okay. So just we have seen data at rest needs encryption and data in motion should also be encrypted. So secure socket layer, transport layer security, these protocols are used to secure data that is being transmitted across the wire. When you go to a secure website with HTTPS at the beginning of the URL, the S signifies SSL. TLS is successor to SSL. Kerberos. Now, Kerberos is an encryption technology that is used to encrypt all communication between two devices. This is one of the authentication protocol, I will say, especially used in Windows environment, Microsoft environment. Now, in Microsoft environment, you know what happens? There is a server which is known as Active Directory, and this Active Directory holds all the usernames and passwords. This is a centralized server. And let us say there is one user from here. User is A1 and he wants to log in to his domain. Let us say www.xyz.com. It is his company's domain. So he will send the authentication request to this server first, okay, using his username and maybe some password. But now which protocol is used here? Microsoft uses Kerberos protocol to encrypt the authentication process. Okay, so there comes the Kerberos. IP security. This protocol was introduced as an integral component of the IP version 6 and borrowed for use with IP version 4. Both IPs provide the logical connection between the network devices for providing identification of each other. The IP security is used to secure VPN. So whenever we establish the VPN connection, so just think of the example we have seen earlier when we have talked about the VPC, the public subnet as well as private subnet. So how you are connecting to the private subnet? We were connecting it using VPN connection. And that VPN is actually using IPsec protocol to encrypt the data. Instant messaging or secure mail. In addition to using TLS to secure the communication between the client and a server, you also might want to use to secure the message itself. So secure multipurpose internet mail extension, SMIME, and pretty good privacy are two protocols that are used for this purpose. Encryption. Algorithms to encrypt and decrypt data. A secret key to ensure that only the key owner can encrypt and decrypt the data. And types of encryption is symmetric, asymmetric, as well as hybrid. So let us see all these encryptions. The goal of the encryption is to achieve confidentiality. In the diagram that is on the slide, you can see that this message is confidential. This message is confidential, is encrypted with a key. So one key is used to encrypt this message, right? And this is the encrypted version of that message. And later on, the same key is used to decrypt the message, and the message will get converted in a original form once again. So this is known as symmetric key cryptography because the same key is used for encryption as well as decryption. Okay. Same key to decrypt the message. The three types of encryptions are symmetric, asymmetric, as well as hybrid, which the following slides will explain. Okay, now symmetric we have already seen. In the previous slide, actually it was the symmetric one. Okay, so see. So the message, hello message is there. This is the encrypted version. It was encrypted using the secret key, and the receiver is going to use the same key. Okay, so probably this sender, not probably, it has to be. The sender has to send this secret key to the receiver. Okay, but that in secure way, okay. So if anybody else is having access to that secret key, then your data will get in trouble, right? So your data will get revealed. So there is a biggest problem with this symmetric key cryptography. And that problem is how securely you are going to share this key. That is the biggest problem. Otherwise, symmetric encryption is supposed to be the good one. It is very fast. It is very fast. Nowadays, even we are using this symmetric encryption. The only reason is that it is very fast. Okay. But how are you going to solve this problem of sharing the secret key securely with the receiver? That we will see in the hybrid key option. Okay. Now, what are the algorithms used for this symmetric key cryptography? Advanced Encryption Standard, AES. Okay, it is designed by NIST, National Institute of Standards and Technology. We can even use, initially we were using DES, that is Data Encryption Standard. Then came triple DES, 3 times, it is using the 3 times stronger key as compared to the DES. Okay, but nowadays we are using AES, that is Advanced Encryption Standard. It has fixed 128-bit block cipher with cryptographic key sizes of 128-bit, 192-bit, as well as 256-bit. A block cipher is a key and algorithm that are applied to a block of data immediately. With AES, the key size is unlimited, whereas the block size maximum is 256-bit. Okay. So when we are going to see our elastic file system, EFS, that EFS actually uses AES encryption. Okay, we are going to look this in our upcoming topics. Not here, not in security, but in our advanced JAWS topic, we are going to see that. Apart from AES and DES, we are having IDEA, that is International Data Encryption Algorithm, 2FISH, as well as TLS, as well as SSL to use symmetric encryption for data exchange. Then comes asymmetric. So we have already seen this, right? So in asymmetric, public and private key will be there. So now user A and user B. User A wants to send this data to user B. So what user A will do, he will encrypt this data using user B's public key. Okay. Whose public key is this? This public key belongs to user B. And once it is encrypted with public key, then the user can use his own private key to decrypt the data. Okay. Okay. You can see the message hello is encrypted with a public key. After it is encrypted, the only way to read the message is use the private key associated with this public key to decrypt the message. What are the example? Rivest, Shamir, Endelman, RSA is the algorithm. Can anybody tell me where have you seen this algorithm in AWS? You remember this? RSA? Anybody? We have seen this. Anybody can recall?
Yeah.
Where we have seen this in AWS? Yes? Okay, so if I go to my EC2 dashboard here, and if, yes, somebody has given me the answer. Yes, Lucky, I want answer. You have seen it, but where? Okay, okay, key pair. So if I want to create a key pair, okay, see, there comes RSA. Okay, so this is Rivest, Shamir, Endelman. So these are the names of 3 people who have created this algorithm. Okay, who has created this algorithm. So we are also having this option ED25519. Okay, so this option is also there, but yes, this is the algorithm we are using in our AWS. This method employs an algorithm based on prime number factorization. So see, this is definitely not the class in which we can create this algorithm. We can learn this algorithm, okay? But lots of mathematics, lots of calculations will be there. But anyway, it is not required here. So Diffie-Hellman is another algorithm, is a key exchange method. So see, it is used to exchange the cryptographic key over public channel. This method uses numbers that are raised to specific powers to produce encryption keys. LGAML. This method uses algorithm based on Diffie-Hellman method, TLS, SSL, as well as secure shell, SSH. These protocols use asymmetric encryption to establish the connection and create the session, and symmetric encryption for data exchange. Okay, so these are the comparisons, symmetric as well as asymmetric. So symmetric is fast and straightforward. Asymmetric is complex and time consuming, but asymmetric is more secure, let me tell you. Okay, so but because it is time consuming, we are using this symmetric in lots of places. Processor speed or process speed, symmetric is fast. Even large amount of data can be encrypted quickly using symmetric, but asymmetric is slow. Keys, just one key is used in symmetric, so it can be 128-bit or 256-bit long key. In asymmetric, 2 keys. Now the length can be 2048 or higher even. Level of security. Symmetric is extremely secure. The risk of compromise if the shared key is lost, that is the biggest problem. Asymmetric provides additional security services. The key is not shared. Manageability becomes complex with more keys. So see, if you are using different keys to encrypt different data and you need to share it with different people, the manageability will become a little bit difficult. It includes an easy to manage key system, security services provided. Only confidentiality can be achieved using symmetric key. But as we have seen just now, non-repudiation authentication can also be achieved on top of encryption or confidentiality using asymmetric key. Use cases. It is used to securely transmit large amount of data or encrypt databases. It is used for authentication or digital signature most of the time. Now let us talk about hybrid encryption. Okay, folks. Now you will be very easily understand this one. Now let us say Alice and Bob. Now they want to go for symmetric key encryption. Okay, symmetric key encryption. So this is the file Alice has created, and because they are going to go for symmetric key, okay, so let us say this is the key Alice is going to use to lock this one, okay, and she needs to send it to Bob now. Definitely it is a digital key, it is not the physical key. So she has to securely share this key with Bob so that Bob will be able to decrypt that data because it is symmetric. It is not public key and private key. So now how hybrid encryption will come in picture, see here. So this is the file that Alice has created and this is the key she has used. Okay, this is the key she has used for encryption. Now what she will do, she will encrypt this key using Bob's public key. This is the file. Which key is used to encrypt this? This key, which is the symmetric key. Okay, this is the symmetric key. But what was the problem with symmetric key cryptography? To share the key securely. But see what she is doing now. Now she is using Bob's public key. This is Bob's public key to encrypt the file. You got it? So see, try to understand, folks. The original data is here. The original data is here. This is the secure data. So what she has done, she has used this key to encrypt it. देखो, इसको लॉक लगाया है और ये लॉक लगाया हुआ की जो है वो दूसरे कबर्ड में रखा है, उसे भी लॉक लगाया है. This is something like this. Okay, so this is the key she has used to encrypt that data. But now she is encrypting it using Bob's public key. And now she will send this file and this file to Bob. Okay, now what Bob will do? Bob will need this key. Definitely, unless and until he is having this key, he will not be able to open that file. But to get that key, he will use his private key. So once he has used his private key, he will get access to this key. And then he will use to decrypt this data. And then he will get access to data. So this is what the hybrid encryption is. Okay, see. So, John, there is a message, hello message. So, it is encrypted using a secret key. Okay, it is encrypted using the secret key. Now, this secret key is encrypted using Sophia's public key. So, the sender is John, receiver is Sophia now. And this is the original data which is encrypted. So see, now when the data reaches Sophia, Sophia will also receive this key. But now this is encrypted. So she will open it using her private key. And once she get access to this key, she will decrypt this message and she will get the hello message back. Okay. So this is what hybrid encryption is. Now see, the TLS protocol, SSL TLS, which we use to communicate securely with the server. Initially, the session is created using asymmetric encryption. So what exactly it means? Now see how it will work. Let me try to explain it. Now let us say this is Google server. And this is my browser. This is my browser. As we have seen, the browser is going to use a TLS SSL connection, right? So what actually happens, So first, my browser will go to Google server, okay? And if I take you to the Google server here now, let us say. So here you see this padlock. So if you click on this padlock and if you go to this connection, it's secure. Okay, so we will talk about this certificate later on. So this is here, I will get the public key. This is the public. Whose public key is it? It is Google's public key, Google's web server's public key. This is the public. So what happens? My browser goes to this Google's web server. Okay, he will definitely, how he is going to authenticate whether the certificate is from the valid entity or not, that we are going to see when we are going to talk about the CA chapter, okay? The certificate authority, that we are going to see later on. But here, the browser will get the public key, right? So to establish this session, he will encrypt some token here with the public key of the server. And if the server is authentic one, he will be using his private key. The server will use its private key to decrypt that data. So once that is done, the next communication, the session key will get created. Okay, the session key will get created, and afterward that communication will happen with symmetric key only, not asymmetric key. Let me go here. I think here they have explained it little bit more properly. So that is all we have done. Okay, let me. Okay, so now let me quickly talk about this. I don't know whether we have taken this in our networking topic. I think I have already taken this in my networking topic. So this SSL TLS stands for Secure Socket Layer Transport Layer Security. SSL TLS certificates allow web browser to identify and establish encrypted network connection to websites using SSL TLS. So SSL TLS certificate is a digital object that allows system to verify identity and subsequently establish the encrypted network connection to another system using secure socket layer, transport layer security. Certificates are used within a cryptographic system known as public key infrastructure. Okay, so we will talk about that later on. PKI provides a way for one party to establish the identity of another party using certificates if they both trust third party known as certificate authority. SSL TLS certificates thus acts as a digital identity card to secure network communication, establish the identity of website over the internet as well as resources on private network. Okay, so we have seen right now this. See, now this is how it will work. The browser and the web server communicate by encoding and decoding information using public and private key pairs. The public key is a cryptographic key that web server gives the browser in the SSL certificate. The key which I have just shown you, right? So there was a public key in the SSL TLS certificate of Google server. So my browser is actually getting that public key from the web server. The browser uses the key to encrypt the information. Now, what my browser is going to do, it will use that public key to encrypt the information, whatever information it is going to send to that web server. Now, only the web server has the private key. A file that is encrypted by the private key can only be decrypted by the public key and vice versa that we have seen. So, if the public key can only decrypt the file that has been encrypted by the private key, being able to decrypt that file assures that the intended receiver and sender are who they claim to be. So see what is happening now. Before the communication happen, right? This is the web server and this is my browser. So this web server has given its public key to my browser. So hereafter, whatever my browser is sending, he is just encrypting it using this public key. And when the data will receive by this web server, it will decrypt it using the private key, right? So this communication is now becoming secure. Just a minute. Okay, sorry. Okay. The server sends the public key in the SSL TLS certificate to the browser. The browser verifies the certificate. So how the browser verifies it? That is, we are going to see in the PKI. Okay. The browser verifies the certificate from the trusted third party and hence it can verify that the web server is